everybody, and welcome back to another video by FunLearn. Now, today we'll be talking about some properties that I think are important before we move on to the properties of existence of additive identity or existence of additive inverse, and the same for multiplication. We first need to know the properties that I'll be writing here right now. So, we'll be talking about the closure property. We'll be discussing these properties for both addition and multiplication. So the first thing that we'll be discussing today is the closure property. The next will be the commutative property. So let me just write that down, commutative property. And the final property that we'll be discussing today is the associative property. So that's the associative property. Now, what are these properties all about? So let's look at addition first. So we'll be talking about closure property under addition operation, the commutative property under addition operation, and associative property under addition operation. So closure property essentially means whenever you're talking about any operation, let's talk about an operation now. In under normal operation chapters, you can define operations any way you like. Since here we talk about addition, we'll be using addition, but this definition for closure property is valid for any operation that you take. So if you want to define an operation, let's say you want to define an operation a dot b equal to a plus b minus ab, you might want to define an operation dot in this format. So in that case, closure property ensures that if, let's say, if this operation is defined on the set of integers, that is the set z, then for closure property to hold, if a belongs to z and b belongs to z, so if I write a comma b belongs to z, then for closure property to hold, a dot b also needs to belong to z. That is what we mean by the definition of a closure property. Now, what significance does that hold when we talk about addition of complex numbers? So what we'll be doing now is, let me just remove these things from the page so that I can get some more space for discussion. So essentially, when we talk about complex numbers, our domain of work becomes a complex number. So if we are talking about, let's say we are talking about complex number z1, and we are talking about another complex number z2. So what will be the operation between them? We are considering the operation addition. So we'll be talking about z1 plus z2. Now, what is special about z1 and z2? The special thing about z1 and z2 are, especially when we are talking about complex numbers, is that z1 and z2 are complex numbers. So as we just mentioned right over here, that if a and b have a particular belong to a particular set of numbers, then a dot b, or the final result of the operation, that also needs to belong to the same set, that also needs to belong to be of the it also needs to be in the same category as the mother numbers, or the mother numbers that you are talking about. So if z1 is a complex number and z2 is a complex number, if these are the parents, if these are like the parent numbers, then their child z1 plus z2 also needs to be a complex number. So that is basically the definition of the closure property under addition. It's very simple. It just means that when you add two numbers, so in simple languages, let me just write that down in simple languages. So if I write that down, let me just change the color. Yeah. So under normal, in very simple languages, closure property says that addition, or let me write it this way, sum of two complex numbers is also a complex number. So that is actually what the closure property boils down to. That is all that it says. If you have one complex number and you have a second complex number, then the addition of those two complex numbers will also give you a complex number. That is what closure property under addition of complex number is all about. That is what it says. It's as simple as that. So that is what we talk about when we talk about the closure property. Now, what do we mean by commutative property? Commutative property is also pretty simple. So let me just change the color so it will be easier to talk about them. So let's talk about the commutative property now. Very simple. Commutative property means Z1. If you have two complex numbers, again, talk about Z1 and Z2, then commutative property essentially means that the order of operation does not matter. So essentially, it says that Z1 plus Z2 is the same as Z2 plus Z1, right? We know that the addition of complex numbers or addition of any number, any natural number, whole number, real numbers, in fact, when you add them, the order does not count. So you add 1 plus 2, that will give you the same result as 2 plus 1, right? We all know this. So that is what we talk about when we talk about commutative property for addition of complex numbers. So if I write that down in simple languages as well, let me change the color to green to keep the parity. So essentially, commutative property says that order does not matter for addition of complex numbers. That is as simple as that, right? That's all there is to it. Now, the final property. The final property is associative property. Again, this is also a very simple property. All it says is, if I take a color purple, if I talk about associative property, what it essentially talks about is it talks about three numbers, right? So closure property takes into consideration two complex numbers. See, you have Z1 plus Z2. So in this entire, in the definition or in the explanation of this property, you are using two complex numbers. You are using Z1 and Z2. Similarly, in commutative property, you are using two complex numbers to explain the concept. You're using Z1 and Z2. And you're saying that by commutative property, Z1 plus Z2 is equal to Z2 plus Z1. So for both closure property and commutative property, you actually need just two complex numbers. The thing about associative property is that here you need three complex numbers. So what essentially associative property is all about? Associative property says that Z1 plus Z2 plus Z3. So the special thing is that Z2 and Z3 are in the first bracket. So you first add these two numbers and then you add Z1 to the result. So this by associative property is the same as Z1 plus Z2, and you add those two first and then you add Z3 with the result of Z1 plus Z2, right? So that is associative property. What does that mean? Essentially, it's pretty much the same except for the fact that Z2 plus Z3, whether you add the first two terms and then add the third term, or whether you add the second and the third term and then add the first term, that doesn't matter. So pretty much the same concept holds, that order does not matter for addition of complex numbers. So let me just put a detour sign over here. It's pretty much the same thing. Only the difference is commutative property uses two complex numbers and associative property uses three complex numbers. So commutative property says Z1 plus Z2 is equal to Z2 plus Z1. Whether you add the first number with the second number, that will give you the same result as the adding the second number with the first number. That's commutative property. So whether you're going home and then to school, or whether you're going from school to home, it does not matter. The distance covered between school and home will always be the same. Associative property says whether you add the order of addition. See, the difference is that here the order is being reversed. So it's 1, 2 and 2, 1. So the order is being reversed. Here the order is not being reversed. We are just taking under consideration, first we are taking just Z2 and Z3, and then we are adding Z1. Here we are taking Z1 and Z2 first, and then we are taking Z3. So this is not a reversing of order. It's just whether which complex numbers we take in the first go and which complex numbers we take in the next step. So that's associative property. And all these this explanation, this equation rather, the expression that I wrote, so Z1 plus Z2, the fact that Z1 plus Z2 is also a complex number, the fact that Z1 plus Z2 equal to Z2 plus Z1, and the third fact that Z1 plus Z2 plus Z3 is equal to Z1 plus Z2 plus Z3. These three are actually talking about the addition property. See, we are using addition property here. We are using not property, we are using addition operation here. Here also we are using the addition operation. Here also we are using the addition operations multiple times, but we are using addition operation itself. Now what we'll be doing is, After we discuss the closure property, commutative property, and associative property for addition operation, now we'll be talking about multiplication operation. So we'll repeat these three properties again for multiplication multiplication operation. So let me just write that down. Multiplication, I'll just write multiply. Since I wrote add in the first go, I'll write multiply here. So this is under multiplication operation. Now, how do we interpret these properties under multiplication operation? We'll use the same approach. So closure property, let's have a quick recap. What was closure property? When you take two numbers from a set and when you operate on them, the result should also belong to that set. This closure property is basically applicable to all operations. So if you take one complex number and another complex number, the addition of those two should be a complex number itself. That was the closure property of addition of complex numbers. So what should we have based on the similarity? What should we have under multiplication? The closure property under multiplication says that when you have one complex number and when you have another complex number, so if you have z1 and if you have z2, these are the two complex numbers that we are considering. If you multiply them, if you do this, or if you are comfortable writing this, whichever you like, if you have two complex number and you multiply them, then that itself is also a complex number, right? This is similar to the addition operation that we did, only here it was the addition operation because we were talking about addition operations. Here we are having the multiplication sign because we are talking about the multiplication operation. So the concept remains the same. When you take two complex numbers and you operate on it, the result should also be a complex number. So when you're taking two complex numbers and you're adding them, the result is a complex number. Similarly, for multiplication operation, when you're taking two complex numbers and when you're multiplying it, the result of the complex number, that is the product of two complex numbers, is also a complex number. So here it was the sum of two complex numbers as a complex number. And if I want to write that down here, then let me change the color to keep the similarity. So here we write product of two complex numbers is also a complex number. It's as simple as that. The concept remains the same. The way of writing also remains the same. It's just that we are changing the operation here. Initially we were talking about the addition operation. Now we are talking about multiplication operation. The concept remains the same. So that is closure property. Now let's move on to the commutative property. So let me change my pen color to green. That is the color that we used last time. So let's talk about commutative property. Now, what was the commutative property in case of addition? It was that order does not matter. So whether you're adding the first one to the second one or whether you're adding the second complex number to the first complex number, it does not matter. Keeping the concept same, we have if z1, let's take it simply. Here we had written plus sign. Here, since we are talking about multiplication, we'll use the multiplication sign. So z1 multiplied by z2 is the same as z2 multiplied by z1. See, the pattern remains the same. Initially we were talking about the addition operation, so it was z1 plus z2 is equal to z2 plus z1. Now since we are talking about the multiplication operation, it's z1 into z2, or z1 times z2 is equal to z2 into z1, that is z2 times z1. So the same thing happens here. Order does not matter. For instead of addition, here we'll talk about multiplication of complex numbers. So let me try to copy this here. So copy, paste, right? And what I'll be doing is I'll be changing it from addition to multiplication. I hope it fits in this line. Multiplication of complex numbers. I did not. Okay, let me try that again. Okay, that fit. So essentially the concept remains the same. If I want to move it a little bit to this side, yeah. So essentially z1 times z2 is the same as z2 times z1. That is what we mean when we talk about commutative property of complex numbers under the multiplication operation. The final property is the associative property. Now again, let's compare with the addition operation and let's derive or let's think about what we can have when we talk about the multiplication operation. first things first, let's write this expression. Let's see what we have. So initially for addition, we'll just skip out the operations and we'll see what we can put there. So initially we had put the we had put the addition operation here. So let's skip that part. Let's keep it blank for now. Then we had z2. Then we had again put the addition operation. Let's skip that part again. Then we had z3. This thing should be equal to z1. Then we had put the addition operation again. Then we had put z2. And then we had put the addition operation again. And then we had put z3. For addition operation, we had a plus sign here, we had a plus sign here, we had a plus sign here, and we had a plus sign here. Now for multiplication operation, of course, we'll have a multiplication sign here, we'll have a multiplication sign here, we'll have a multiplication sign here, and we'll have a multiplication sign here. That's right. So for addition, for associative property under addition, we had the order does not hold, and basically the concept remains the same. Whether you multiply the second number with the third number and then you multiply the first number with it, or whether you multiply the first number with the second number and then you multiply the third number with it does not matter. So essentially that is the associative property under multiplication of complex numbers. So today, in today's video, we talked about closure property, commutative property, and associative property for addition of two complex numbers. So we have these three properties for addition of complex numbers, and we have these three expressions for multiplication of complex numbers. Why I did this is because these tend to be discussed before the existence of additive identity and existence of additive inverse, and existence of multiplicative identity and existence of multiplicative inverse. So I felt that we need to discuss these three because in most courses you will be taught this before you come up with the existence of the identities and inverses. So next week we will be talking about I think I'll be dividing into two videos. So next week we'll be talking about the existence of additive identity and existence of additive inverse. That is, we'll be taking up addition operation next week. Following up, the next to next week we'll be talking about existence of multiplicative identity and existence of multiplicative inverse. So next to next week we'll be talking about the multiplication operation. And I would really like it if you could subscribe to my channel for more such videos, for more such helpful videos, and please like, share and comment.